All right. Well, thank you, Greg, for joining us today to talk about the sun and observing the sun. Um, we'll go ahead and get started here, and I'll turn it over to you.
Okay, thank you very much. I appreciate you having me out today, even though I get to sit in the comfort of my own living room. But this is an exciting time. We are, in fact, in the big year or heliophysics big year. We are seeing more activity than we have in many years, and I'll get into that in a little bit. So, we're going to talk about how we observe the sun. And these are the step by step instructions how to safely observe the sun. Don't look directly at the sun. It's that simple. They told us that as kids. Any questions?
Not yet.
Not yet. Okay. So this is in fact the sun. Uh, in my research, I actually tried to figure out because we hear all the different names for the sun. And in fact, the name for it is sun. It is Old English, German, and Norse kind of combined, which makes me feel real good because of Swedish heritage. It means my ancestors brought more to this world than Vikings and lutefisk. In Latin, it's known as sol or sol. It is used in two different forms. If you see it capitalized, it is used to differentiate our star from all the other stars in the sky. As for if it's lowercase, that is a period of time similar to a day. So when they talk about the Mars rovers, they say Sol 500. They had to come up with a unit of time based on the fact that not every place is going to have a 24-hour day. Looking at our sun, it is 1.9885 times 10 to the 30th kilograms in weight. If you want to get out your calculators, I'll let you do the math. You could fit 332,950 Earths into the sun. This is massive. And in reality, it's pretty average, even though it takes up 99.86% of all the mass in our known solar system. When I say known solar system, uh, I love working with kids because they're going to tell me there's 8 planets in the solar system. I know a lot of people here say there's 9 planets in the solar system. Amazingly, I'm going to tell you right now, we don't know how many planets are in the solar system. And that's simply because beyond Pluto, we know there's something there. We know it's big, but we haven't found it yet. Brightness of our star, it is 85% brighter than the Milky Way, which we're in, and it is the brightest object in Earth's sky. Now, in reality, it is so bright it actually causes the second brightest object in the night sky, and that would be lighting up the moon. And the rotation of the sun takes about 28 Earth days for it to actually, in the swirling mass, come around and we see the same face again. That's why when we had fun, the exciting things like earlier this week, they seem to go away. For the size of the solar storms, I would expect sometime mid-November, we might get to go out again and have some fun with it. Okay, oh, I missed that. So we have several layers to the sun. The core is about 20 to 25% of the solar radius, and the temperature is 15.7 degrees or 15.7 million degrees Kelvin. It is incredibly hot. The radiation zone follows that, and it's somewhere between 7 million and 2 million degrees Kelvin. This is where we're actually getting all of our heat. This is where we're getting the radiation that helps sustain us. And life would be impossible without the sun. After that, there's the tachocline. It's a solar dynamo. It generates its magnetic field. It holds it together. This is where those magnetic storms that we have loved so much this week come from. And then the convective zone, it's almost up to the surface. It is solar plasma. It is not dense or hot enough to actually transfer a lot of heat energy outward. It's helping hold the sun together. And then there's this photosphere, which is what we see all the time. And that is, it becomes opaque to visible light. There are areas that are cool enough we found in the sun for simple molecules such as carbon monoxide and water to exist. So from what they are saying, there is water in the sun. And time-wise, we are at a solar maximum. This goes on about every 11 years. What's really cool about that is we are seeing lots of things going on. It was great at my school. Our science teachers were talking to me and they're like, hey, you got any new things on the sun? It's kind of boring. Nothing's going on. I'm like, yeah, we're on a lull. Just wait, just wait. And then now they're very, very excited with what's going on. So there's our solar maximum, and you're actually seeing the sun at its solar maximum. And some of the lines out there are corneal mass ejections. That is some of the stuff that's been fueling our activities at night. And of course, there's magnetic storms. The most recent auroras, they have recorded auroras as far south as Pigeon Forge, Tennessee. Fairly far south. I know where other areas, southern Illinois had it. They were bright enough that the city of Chicago, you could actually see the auroras, even though all the lights were on. So this has been an exciting time for the sun. I'm sorry to say we'll start to go down into a lower amount of activity, but knowing it's nice to know it's going to come back to us. And we should be expecting storms going on. Now, in Illinois, I'm not real far south of southern Illinois, but I'm far enough north that we occasionally see this. I know it is not absolutely as spectacular as you folks get to see, but this is me wandering around my yard and just taking pictures in the road and seeing what I could see. Now, what we're looking at color-wise, when you see the reds and the pinks, that's high altitude excited atomic oxygen. The green is oxygen also excited, and that's at a lower elevation. And the purple and the blues are ionized nitrogen. And that's what gives us our colors. Down here, we didn't get to see as many of the lines and the really awesome swirling. I got to see that once in northern Wisconsin. It's something to see. I know through all of this, and I saw a photo of it. Iceland actually got white auroras this past week, and they are absolutely phenomenal. So we may have one more night of the auroras. I'm not speaking on it. You may see them if you want to go out, because in the observation, we're also at the point that there's a comet that's going to be at its best viewing the next few days. So how to observe the sun? And our reality, this is the safest way. This is how they used to do it. And this is a much fancier version than a lot. And that's the old pinhole camera. It's a piece of paper, something to help focus. They're using a tripod and binoculars, cap a lens. This really works. And this is where for years, and I mean hundreds of years, this is how we observe the sun. This is the safest way to observe the sun. And even then, this person, if they do a whole lot of observation with those binoculars, they have probably ruined the binoculars. The sun is incredibly bright, incredibly powerful. Galileo was first observing the sun on June 23rd in 1613, and he was the first person to observe sunspots. And these are his actual drawings. So he was the first person to see the sunspots, which are cooler spots on the sun. As we were continuing and learning more, they found out that they needed a higher elevation, hilltops, mountaintops. If you notice, there's a reason there's more observatories around you folks than around me, but also the need for stable air. And that's why a lot of times you see it's not just because it looks pretty. Your observatories are near lakes or larger bodies of water, because you also need the clear skies and the higher ups. And from that, this is one of my favorites. This is the Yerkes Observatory in Williams Bay, Wisconsin. It is home of the world's largest refracting telescope. This was built by some people who talked a businessman into the importance of studying the heavens. It is absolutely beautiful. If you are going to Wisconsin, I highly recommend making a visit of it. If you can do it around Christmas time, they have a glass Christmas tree that is just phenomenal. What is really cool about the Yerkes Observatory is it was a part of the University of Wisconsin, or I'm sorry, University of Chicago for a long time. And the University of Chicago decided they didn't want it anymore, and they shuttered it a few years ago. And right before COVID, the people of Williams Bay were so upset that they lost this and it wasn't available. They banded together and they bought Yerkes from the University of Chicago, and it is back open to the public to study, to tour. It's just a beautiful setting, and of course, to bring back the observations. So, in reality, when we want to, for a casual observer, there's three different ways for us to primarily do it. I've seen even people for like the eclipse set out a colander so it creates some shade so you can look. The first is if you still have your eclipse glasses, and I got a pair here. These are great. You can actually look at the sun for short periods of time with them on. Just make sure the lenses are not scratched, they're completely covered, and they cover to the side. What's nice is if they're saying, oh, there's going to be a lot of sunspots, you can actually look directly at the sun again for a short period of time and see the sunspots with your eclipse glasses. If you have young kids, and this is one we did with my sister-in-law's class, cut a couple of holes for the glasses and put them on a paper plate and then put them on the young people's faces. That way they don't play with it. You don't want to injure those tender eyes. In the center is a lens filter that will protect your cameras, your telescopes, things like that. And finally, this was used quite a bit. If you've got a welding helmet, they work fantastic. They will completely protect you. And that is one of the dangers of staring in the sun. Everybody's like, well, so you see a few spots. Yes. So maybe you're not going to have perfect vision forever. Obviously, I don't. Here's the big thing, and I'm going to use it. Has anybody in the audience, and I won't see hands, has anybody ever experienced snow blindness? Okay, what snow blindness is,
Got one. Yep.
got one. If you don't realize what snow blindness is, you've actually sunburnt your eyes. It hurts. It takes a long time to heal. I don't recommend it. So we did some different forms of observation. They were using some telescopes. They were using indirect observation. They started sending some probes. The Ulysses probes were probably the most famous. They didn't get real close, and they did a flyby and gone. Not great for gathering information. So what we needed to do was find something that could really, really handle the sun. And we got this. This is the Parker Solar Probe. Its mission was to touch the sun. It weighs 1,010 pounds. It's on a 7-year mission. It's going to make 24 passes of the sun, and 21 of them have happened. The last one happened just 5 days ago. So it will zoom by, go into, catch an orbit, get shot back out, and keep using primarily Mercury to maintain it. What's interesting about this is the shielding on this device is 4.5 inches thick. That's about 2/3 of a dollar bill. And it's made of carbon composite. Based on what they've done in the building, it is able to withstand temperatures of nearly 2,500 degrees on the outside of that spacecraft. So it could actually survive dripping a McDonald's apple pie filling onto it. What's really cool is this thing is so well designed and meant for absolute punishment. The inside of the instruments by the shielding only reaches 85 degrees. That is a huge advantage. The instruments are that's doing a fields experiment and integrated science investigation of the sun. It has a wide field image for solar probe and a solar wind electrons, alphas, and protons. That's a big one for us to look at. That could actually, the solar wind could be a form of future propulsion in space. If you want to look into it, the Planetary Society has at least one ship up now that it flies by a solar sail. So where do we get the Parker or the solar probe? From this gentleman. His name was Dr. Eugene Parker, and he was the pioneer of modern understanding of the sun. He was with the University of Chicago. He was the person who predicted and mathematically said it should be the solar wind. And what solar wind is a constant outflow of solar materials. He did this in the 1950s. He was proven correct, interestingly, on July 20th, 1969, because we all know what happened on July 20th, 1969. If you look at the photos of the moon landing, a couple of them, you'll see kind of a little gold flag. And what that was an experiment to actually see if there was a solar wind. And what was very interesting is almost as soon as Colonel Aldrin had it set up, they started detecting solar wind. He's also the first person to ever witness a spacecraft bearing his name being launched. There he is prior to his launch in 2018. And unfortunately, we lost Dr. Parker in 2022 at the age of 94. What the Parker Solar Probe is, and there it is, artist rendition of it approaching the sun. It is the fastest man-made object to date. It goes 430,000 miles per hour. And based on that, it could orbit our Earth in 3.3 minutes. How do we build something like this to survive that horrible area? Because there's nothing they say can live on the sun. We need it to live, but it can't live it. What we have to do is understand the idea of heat versus temperature. The temperature is incredibly high. It is the speed of the particles. I'm going to use the example of this because everybody's got their favorite pizza place. So what we're going to do, we're going to go to the pizza place. We're going to have them set the pizza oven, let's say 212 degrees. And we're just going to roll up our sleeves and we're going to stick our arms in there. Nothing's going to happen other than we're going to feel some warmth because we're feeling the temperature. Heat is the transfer of energy. And the example I would give on that is while we're doing that, they're going to get one of the big pasta pots out and they're going to fill it with water and get that up to 212 degrees also. None of us are going to be willing to put our hand in there because we know what's going to happen. That is heat. So what they have actually done is it can survive incredibly high temperatures because it's moving fast enough and its shielding allows it to ignore the heat. It also has retractable solar panels, which you can see there. A small portion at any point does still stay out. And to keep it cool, it only requires a gallon of water. It is, and right now it is its closest pass is 3.9 million miles above the surface of the sun. I don't think we're ever going to be able to get it back. So probably as it's coming to an end of its life, one of our last missions for the small amount of control we can do with it. My guess is we will actually try to directed into the sun and get as many readings as we can possibly. So we look up in the sky and we see what the sun is. This is to date the most close picture of the sun, and this was sent to us by the Parker Solar Probe. I know it kind of looks like modern art or a close-up of an orange, but we're actually looking at the sun. And that is absolutely incredible. I'm looking forward to, even though my kids are fairly well grown, I'm excited to see what maybe my grandchildren, excuse me, my dogs wanted to join in on the presentation, what they're going to learn about it. And then to give you an idea, though, as big as the sun is and important as it is, one last photo to show you. This is a very famous photo. It was taken in the 90s. As a matter of fact, it was taken on February 14th. I believe it was about 1991. And what you're looking, anybody know this picture?
No. Is that the pale blue dot?
This is the pale blue dot. So that little light right here, if you can see my cursor or mouse moving, that is us. If you notice, we can't even see our sun, and that's out at Pluto. So for as important as it is, you get far enough out, people aren't going to ever pay attention to it, or if there's something else out there. I'm curious to see at some point, we maybe find another civilization and see what they have done to observe our star, and maybe what constellation they see we're a part of. Now, I know I flew along and threw a lot of stuff at you. This was really, I tried to keep it as unboring or bogged down with numbers. So that's kind of what I've got. I know it's a little short, but do I have any questions?
Yeah, we've got one here. So
You said that there was a white aurora in Iceland. What causes the white aurora?
That is based on their atmospheric conditions. I'm guessing it is probably based on they are far enough north and they regularly see the lights that the atoms were so energized that they hit the point that they just didn't even have any color.
Wow.
So they basically achieved white light.
That's pretty crazy. So the Parker Solar Probe, there's a couple other solar probes, isn't there? That
Parker is the one going right now. They haven't named them or said too much about them. They are preparing other ones to do similar missions.
okay.
Based on the success of the shielding, they're also, I think, hoping that we will be able to use some of that shielding to go into Venus, which the last probe that went survived 90 seconds in the atmosphere, and that was a Russian probe. And from the description that even NASA got, that they basically put a tank in a battleship to send it down, and the atmosphere just ate it. So they're hoping something like this will be able to we'll get a better idea of what's going on in Venus, because one way to deal with the greenhouse effects on Earth is to learn about the greenhouse effects on another planet.
Gotcha. I was thinking there was ones stereo A and B that were also up there. I don't know if you've heard of those.
Those I haven't found a whole lot on. Obviously, right now, one of our big ones, everything right now, or so much of it is web, which I will tell you folks now, if you're enjoying the photos of the web, just wait until the next one goes up. It's gonna, from what I understand, the Galileo Space Telescope is gonna make web look like a toy.
Wow. Looking forward to that.
Yeah.
Any other questions?
Do you have a slide of the different layers of the sun?
You know what? We're gonna cheat. Let me jump around.
I'm just curious, because like when we look at with our H alpha telescopes, I'm just curious at what layer that, is it the chromosphere that we're looking at? In H
The
alpha?
the chronosphere. Well, yeah, we're looking at, we see the photosphere. There we go. Pull that. Okay, hopefully is that
That's
so
still your presentation, so
okay, so
you may have to unshare and reshare.
now I can do this. Go to my back to the presentation. And new slide. And paste. Okay, so what we're talking about with that is the core is very large. The radiation, the convection zone, not huge. And then of course there are some others. The corona is the very far out area. The photosphere, that is visible from Earth. But you were asking about which one, the chronosphere?
Chromosphere, yeah.
That is basically just the most outside area.
Okay.
So you are looking at a chromosphere. This photosphere is where it changes, the light changes to a point we can actually see it.
And the sunspots are just cooler spots?
As I understand, they believe those to be cooler spots. Flares are obviously ejections, a hotter area. They say there's a corneal hole. I have yet to see it or see a whole lot of ideas of it. And then in the corner, you can see that tiny blue dot, and that gives you an idea of how we are compared to the sun. But the sunspots actually aren't on the surface of the sun. They are taking place more in the photosphere.
Okay. And what do they think causes the sunspots? Is it just like a magnetic flux or?
Probably a magnetic flux, part of the whole fission of the sun. Occasionally, maybe something misfires. Could be a collection of just a different of the helium as it's burning off. Unfortunately, we haven't really it's going to be a while before we get too close to be able to really study them and get a chemical sample of it. And some of our best instruments, something like the Webb, which has amazing arrays, and we could do all kinds of different scans with infrareds and all of that. To face it at the sun would actually kill it because it's for the Webb to work, it hides behind the Earth's shadow. So that's why we'll never get a good photo of the sun with that. So our best bet is to build something that we understand isn't going to work very long and send it to get that look.
So what are the particles that are in the CMEs that's been hitting the Earth?
Excited, it's electromagnetic energy. It's what particles it hits, comes out with us. Obviously, there's probably going to be some hydrogen, is what's fueling the sun as it burns. It creates helium. There might be a little helium, but basically, it's radiation energy that pushes it along.
So you had your up a couple of slides there that you had the picture, the closest photo of the sun, and it
let me
had
get
some
that.
um, a white spot with also some darker spots around it.
From what I've been able to read about it, is the white spot is, they believe, a flare. It's very interesting. If you notice, they all seem lined up and in a cooler spot. So another thought could maybe be, if those are sunspots, maybe that's an area that sees a lot of flares. And after the flare has gone, we're seeing it recondense, cool off a little bit.
Hmm.
What I'm guessing is this area up here is not necessarily corneal anything being released. It is probably more of like a prominence. We'll occasionally see in the drawings, a little bit of the flame, energy going out, coming back into the sun.
Gotcha. Well, thank you.
Not a problem.
Yeah. Any other questions anybody has? Okay. Well, thank you, Greg. We appreciate your time and
Appreciate it. Thank
Yeah.
you for having me. Hopefully I didn't bore people too much.
no, it was great.
All right. Thank you
Thank
for
you.
your time.
Have a good day.
You too.